Hello everyone, good evening.
Good evening.
Good evening, sir.
Okay, so today we have session for week 6. So have you all covered the week 6 content? I know, or still in progress?
No,
It's still in progress.
Okay, so
At the
yeah,
end of the class, can I ask few questions from week 5 credit assignment?
yeah, sure. And okay, so do you guys have doubt from week 5 or week 6 majorly today?
Week 5, I got few questions got wrong in credit assignment, so I want to ask those.
Week 6 will also.
Okay, I think we can start with week 5 graded assignment, then move to week 6 activity if that's okay with everyone.
Okay, sir.
Okay, so which questions in week 5 did you
So
find?
like I got wrong in 1, 2,
Okay.
because my set of questions are different. Let me check again.
Yeah, it's just the numbers will be different. Rest all things will be
Yeah,
different.
I got like this one also. 30 factorial by 27, that one. So
Okay.
3 to 4 questions I got wrong there.
Sir, I have a doubt in 9th question.
Question number 9. Okay. Okay. So, the first question, were you guys able to do or you guys faced
Yeah,
difficult?
that got wrong. Mine was 4 registers and 8 cover papers.
Okay, so how did you approach this one?
Like I thought like each register needs each cover, means one cover paper. So
Yeah.
I just multiplied 4 multiplied by 8. Yeah, that's what I did.
4 multiplied by 8. No, why did you do 4 multiplied by 8?
Like
In
if I
general,
4 cover for a time, and then again if I change another 4.
see. Okay, so you had 4 register, right?
Right.
Register 1, register 2, register 3, and register 4, right?
Right.
And you had 8 different colored cover paper, right?
Yeah.
So for first register, how many options do you have for to cover it with cover paper?
8.
8, right?
Yes.
Now first register is covered with a cover paper, so you are now left with 7 cover papers only, right?
Right.
So for second register, how many options do you have?
7.
7. Now again you have 6 cover paper left because you have already used 2 for the first 2 register, right?
Right.
For the third one, you will have
6, and the next one is 5.
5, right? So that's how you should approach this. So what was the logic behind 4 times 8? Like, why did you do this?
I think what I did, like I thought like each register needs each paper. So first time it would be 4, and again another set of 4 papers are there. So again another 4. So 4 into 4 16, and the next time also 4 into 4 16. That's what I did.
Okay, you did 4 times 4 times 4. 4 is to the power 4 you did.
Yeah, I just 16 plus 16, I just did 32.
16 plus. Okay. Okay, so now is it clear with this, like how to approach these questions? Okay. Question number 2, are you guys able to do or?
Yeah, one also.
I have doubt in this.
I have also doubted this.
Okay.
Excuse me, sir, in the first question, why can't we use combination formula?
Combination formula you can't because it matters. First of all, you will be using permutation, right? Because it matters if you're using the red colored cover paper for first register or blue color. So it matters, right? Order is mattering over.
Sir, why does order matter?
Why does order matter? Because see, uh, wait, let's replace it. You have 4 registers and 6 cover papers of different colors, right? So if I cover R1 with red, and let's say this with blue, so this one with green, and this one with pink. Or if I cover first register with pink, this one with green, blue, right? So these two will be different places, right? It's mattering that at what registers I'm using which color, right?
Sir, they're all 5 identical books, right?
Yeah, 4 different registers and 8 different cover papers. So here order will matter. Like suppose if you consider it as your subject copies of schools. So suppose this one is the register for Hindi, this one for maths. So it do matter if you're covering Hindi register with red color or pink color. Right? It's a different.
Okay, sir. Yeah, got it.
Second question. Okay.
Yes, mine was like 9 classmates instead of 3.
Okay. So for this, suppose you have 3 students in general. Okay. Classmate 1, classmate 2, and classmate 3. Okay. And there is a group photo where teacher will definitely be in the photo, and rest all these have choices whether to be in photo or not, right? You have to make all the possible variations they can have for group photos. So C1 has 2 options, either be in photo or not, right? C1 can be in photo or not be in photo. So he has 2 choices for the photo, right? Similarly, C2 will also have 2 ways, and C3 will also have 2 ways. So in total, there are 8 ways. But the condition is given to you that at least one classmate should be in the group photo, right?
Right.
So suppose all of them chooses to not to be in photo. In that case, there would be 0 classmates in the photo. So we need to subtract that one single case when all of them are not in the photo.
So like if I consider 9 students, then mine was getting like I got the 71, but the answer will be 500.
Right? For 9 students would be 2 times 2 times 2. For the 9 times you will multiply by 2, right?
Hello, sir. Will sir please repeat that -1 concept?
Okay. See. Okay. Firstly, you are clear with the statement of the questions. Like 3 classmates could not agree on who would stand in the group photo along with the teacher for the yearbook, right? So in general, what is happening is this is a group photo. Teacher would definitely be there, and suppose there are classmates 3. So they could not decide who would be in photo or who would be not. So they decided to make all the possible, like we need to find out what are the possible ways they can take the photo. So what possibilities could be that only C1 be in photo and C2, C3 are not in photo, right? Next one could be that C1 is not in photo, C3 is not in photo, only C2 is in photo. Another one could be only C3 is in photo, rest all of them not. Next, it is possible that both C1 and C2 are in photo, but C3 is not. C1 is in photo and C3 is in photo, but C2 is not. Would be C1 is not in photo and C2 and C3 are in photo. The last one, all of them are not in photo. So here in general, if you look at it, is each classmate has two ways for photo. Either he or she will be in photo or not in photo, right? So in general, there should be 8 ways for 3 classmates. But the next statement of question said that there is at least one student with the teacher in the photo. So you need to subtract that case where no student is in photo, right? So if you look at it, there is only one case where no student is in photo. You need to subtract that one case. When all of them decided not to be in photo, that case you need to subtract, right? Is it clear with everyone? Still?
Yes,
Yes, sir.
Yes, sir.
Okay, so we can move to next question, right? This one is clear.
yes.
Okay, this one.
Yeah, this one also.
Okay, so, how did you approach this one?
So like I did like just a minute. So I did first like VIP plate with first three alphabet and then 2 numbers where repetition allowed. So for 3 alphabets we have 26 options for 3 and
No. You can only use these alphabets, right?
okay.
Shouldn't be
Like
nine
plate with
options.
The 9
standard-
alphabets actually.
Yeah, 9 alphabets. So 9 options for alphabets.
Yes.
And also in general, whenever alphabets is mentioned only, you can take 52 possibilities, lowercase and uppercase.
Yes, sir.
So you only take 26 when it is mentioned that either lowercase is mentioned or uppercase is mentioned. Then it is 26 possibility. Okay. But in this question, you have to use only these 9 alphabets.
So like my process was like repeat so 9 if here is 9 alphabets then 999 for 3 places and then again 0 to 9 means 10 numbers are there.
Yeah.
So 10 and 10
Yeah.
and all multiplied with each other,
Yeah.
right?
Basically, sir, it is going to be
So the fifth
9 to
question,
the power 9 to the power the numbers are actually
Yeah.
yeah, and if then we have to multiply it, then again 10 to the power the number. I mean
Yeah.
the combination number.
hello sir.
Yeah.
So the fifth question in graded assignment.
Yeah. We'll come to it. So fourth one also you need to just find for normal plate, right? And then add
Yes.
them both.
Yes.
Clear, right?
Yeah, that's it. I did the mistake there. I considered 26 instead of 9.
Okay, question number 5.
Yeah, that's also neat.
Okay, so how did you guys approach this question? Like, what was your first step after reading these statements?
For n into
Sir, first
n plus 3 factorial equals to 5 times of n factorial. 5 times the number of ways to arrange a sir. Sir, but I was not able to solve it properly.
Yeah. Okay, see, if you go statement by statement, Ram has n trophies, right? And which are to be placed in main cabinet, which has only space for 2 trophies. So in general, out of 9 trophies, you can only place 2 trophies in the cabinet, right? If the number of trophies is increased by 3, then the number of possible ways to arrange the trophies. First, okay, so do you guys know what does the word arrange means? What does the word arrange implies in this question?
Permutation.
Permutation, right? Arrangement means this A at first place and B at second place, or B at first place. This is different cases. Whenever there is an arrangement, order matters. Okay? And whenever there is a selection, it doesn't matter in which order you select.
Combination.
What matter is you are just selecting, right? Whether you select A first or B first, these will be the same. Okay. So in that case, order doesn't matter. Okay. So here it is given that Ram has n trophies, right? Out of which he has to arrange 2 trophies in his main cabinet. So 2 places. So total number of ways to arrange these n trophies would be, at the first place he could have any of the n, and for the second place he could have any of the n minus 1, right? Clear till this step?
Yes.
The
Yes,
next
sir,
step
that
it is
means
saying that, yeah, Ram, if the number of trophies are increased by 3, now Ram has n plus 3 trophies. So now number of ways to arrange would be n plus 3 ways for the first place and n plus 2 for
Plus
the.
3 minus 1. Yes.
n plus 2.
Now if you look at the question, if the number of trophies is increased by 3, then the number of ways to arrange the trophies in the main cabinet becomes 5 times the number of ways to arrange n trophies.
So here we will not take factorial.
So why would you take factorial? Factorial is when you have to arrange all the n trophies in the n places.
So it's very confusing when to take factorial and when not to take.
Okay. See, if I say you have 5 trophies, right? And you have 5 places to arrange it. Then for the first place, you can arrange any of the, you can put any of the 5 trophies, right? Then for the second place, you will have remaining 4 trophies as a possibility, right? Then 3, then 2,
3,
then
then
1.
2, 1.
In that case, it will be 5 factorial when you have to arrange all the n objects at the n places. But here we have to arrange only 2 objects. Like out of these n, we are arranging only 2. That's why for the first we have n possibility. For the second we have n minus 1.
Yeah,
So
the main cabin. Sir.
Yeah. Okay. So now it is
So we
given
will
that,
multiply
Okay,
5
then
into
we
n into n
n
minus
into
1.
n
yeah,
minus
this,
1 equals to 5 times of that n plus 3 into n plus 2.
so this equation is given to you by the question, right?
Yes.
Yeah.
Now we can easily solve this one.
Yes. Sir.
Square plus, then it would be 6. 6.
Minus 6, sir. Minus
So
6.
minus 6.
Minus 6,
So
sir.
it will be minus 6.
Minus 6 would be square minus
12.
4n, sir, 4n plus 2 and n minus 3 is equal to 0.
So from here you will get n equals 3 and
And minus 1.
minus 2 by 4. So number of trophies can't be in negative or can't be in fractions. So only possibility is that n equals 3, right?
Yes, sir.
Is this question clear?
Yes, sir.
Yes, sir.
Okay. So one thing to keep in mind from this question is the word arrange and select. Okay. Whenever you see the arrange, it gives you a direct hint that order do matter and you have to go for permutation. Okay. Any doubt in the first 5 questions till now, anyone?
Sir,
No, sir.
hello, sir.
Yeah.
Sir, when to use n to the power r formula?
When to use and okay. Suppose you have n objects, okay, and you have to arrange them at r places. Or let's take the number. Suppose you have 5 objects and you have to arrange them at 3 places. Okay, and it is possible for you to do it with repetition. It is like you are, another word you can say, you have 5 balls in a bag. Okay, and you are drawing one ball noting down the color and then putting it back and then keeps on doing it. So for the first place, you could have any of the 5 balls, right? Then again, since it is with repetition, again for the second place, you can have any of the 5 again. And for the third as well. So in that cases, you use n raised to the power r whenever the question is with repetition arrangements.
And
Okay.
here order doesn't matter.
Order do matter.
Order matters.
Yeah, order will matter.
So
But-
repetition and replacement are the same, no?
Yeah, these are the same. Okay. Question number 6.
Yes, sir.
Clear to all or shall I?
Clear, sir.
Yeah. Okay. So here the only thing to be taken care of, that first 3 students who completes the award project will be awarded. So it doesn't matter which student is getting the award first, second, or third. Only thing
Here order doesn't matter.
order doesn't matter. Only thing is matter to us is that these are the 3 students getting award. So that order factors is to be like those duplicate cases should be removed by dividing by 3 factorial in my questions. Okay.
So can you again tell? I couldn't hear.
Okay. Suppose here we are saying that the 3 students to do the project, given project within the 2 days will be awarded, right? So suppose student A finishes first, student B finishes second, and student C finishes at the last place. Or suppose student C finishes first, B finishes second, and A finishes third. So these 2 will be the same because at the end, the students who are getting award are A, B, and C only, right? It doesn't matter at which place they, because there is no separate award for the first place, second place, and third place. It is same. So they are awarded. Only these 3 students should be awarded in any of these cases, right? So order doesn't matter over here.
So how to do this sum without knowing the combination formula? Suppose we don't know the combination formula.
Yeah,
Then
no
how
need
can
to
we
know
do
that.
this sum?
By counting principles, you can do. Okay, see. In my case, there are 30 students, right? And 3 will be awarded. So for the first place, any of the 30 students can come, right? For the second, any of the 29. For the third,
आंटी आपको पैसे दिया क्या मम्मी ने?
and 28. Okay. Now I know that order doesn't matter. So I know that case ABC, ACB, BSC, BCA. These 6 cases comprises of only one case, right?
Yeah.
So I need to, and I know that all such 6 cases will comprise only one case. So in general, within this, my each case is counted 6 times, right? Because this is also counted in this case is also counted in this calculation, all these 6. So in general, I know that my one case is counted 6 times in this. So to overcome that, I need to divide by 6. And now you can convert it into the factorial terms. That would be.
Sir, here why we are we considering 3 factorial in the denominator?
3 factorial in the denominator because see, at the end, my only 3 students should be awarded, right?
Right.
We are not distinguishing that the first one will get gold medal, second will get silver, third will bronze. The only thing that matters is these are the 3 students which are awarded.
Yeah.
So either A finishes first, B finish second, C finish third, or they finish in this order. In all these 6 cases, students awarded are A, B, and C only, right? So that's why we know that. And when we do this 30 times 29 times 28, in this we consider all these 6 cases to be different, right?
Um,
So I know that my each case is counted 6 times in this.
Okay.
So to overcome that, I need to divide by 6, which is nothing but 3 factorial.
Got it.
Is it clear now?
Yeah, but if question was like that, like order matters, then what would be the approach?
Then it would be simply this. Because then it would matter that who is finishing first and who is finishing second and who is finishing third. Then it all would be different cases, right?
Got it.
It's a perfect example of combination.
Yeah. That's how you can distinguish between permutation and combinations. So that's the permutation. Whenever order matters, permutation order matters. Or in other words, arrangement is same as doing the permutation. And selection is same as going for combination, where order doesn't matter. Okay?
For instance, if a question asks about selection and order doesn't
Yeah.
matter, we can say combination. But when it includes that order will be mattered, then it would be permutation, regardless if it is saying selection.
No, it won't be selection and order matters.
Okay, it can be.
Because if you are doing selection, you are here you are doing selection of 3 students out of 30. So it doesn't matter in which order you are doing.
Okay.
These are the 3 students you get at that. Okay. Everyone clear with first 6 questions till now?
Yes, sir.
Yes, sir.
Question number 7.
Yeah.
Yes. So I think we did similar one in the solve with the session as well.
Yes, sir.
Yes, sir.
Okay. Question number 8.
Yes, sir.
It's just a simple equation if you know the formula for sum of n natural numbers, right?
Yes, sir. N plus 1 divided by 2.
Yeah. Okay. Question number 9.
Yes,
Yes,
sir.
sir, I have
Yes, sir.
problem, sir.
Doubt. Okay. So how did you approach this? What's your doubt?
But
Zero
sir,
at the first place.
Sir, how can the roll number 000 is valid?
It is valid.
that's what
Most
I
universities
selected
have.
the option second.
Because
if-
I have chosen the option number 10 raised to the power in 1 into 9, but the correct answer is 10 raised to the power 2, which means it is including that 0 in the initial position.
Okay. Is roll
Yeah, it's
number
categorical variable.
numerical or categorical variable?
Yeah, it's categorical for sure.
Categorical variable, right?
Yeah.
So it doesn't matter whether it starts with 0 or not.
Sir, but if a 9-digit number, first digit is 0, then we can say it is 8-digit also. 0 does not have any.
You can say that in case of numerical. Because suppose if I give you some numerical number 0, 1, 2, 3,
Yes, sir.
it would be 3-digit, right? But suppose I give you a 4-digit categorical variable.
Okay.
So numbers are not making any sense. It is a 4-digit. You are filling 4 digits. It is categorical variable. 0, it is not meaningful numbers, right? It is just you are filling 4 digits. That's all.
Okay, sir.
So that's the linkage of week 1 content over here.
Got it, sir.
Question number 10. This is just a simple factorial of
Yeah, no, that's fine.
clear, right?
Yeah, yeah.
You all know that 0 factorial equals 1.
Yes.
Okay, any other doubt in this related assignment before we move to week 6?
Hello.
Yeah.
Sir, can you please explain the question number 7?
Question number 7.
Yes.
Okay, how did you approach this one?
Sir, actually, I make a pair-wise selection. Yes,
Pair-wise selection, like
with yes or no, sir.
yes or no, but student can also refuse to respond, right?
Yes.
So each student has 3 options in general.
Okay.
So if there are 5 students, each student has 3 ways of answering. So student 1, student 2, 3, 4, 5. So student 1 has 3 options, either to say yes or no, or to refuse, right?
Okay.
Similarly, student 2 will have 3. Each has 3, right?
Mhm.
So it's nothing but 3 raised to the power 5.
Got it, sir.
So what about the case where all the students refuse to answer the questions?
Yeah,
Can
that's
we
also a
consider
valid.
a response?
Yeah, it is also a response. If someone is refusing to respond to your survey, it is also a response. Because in surveys, many surveys, there are sometimes some personal information is asked, and you can definitely refuse to respond, and there would be possibility when all the users refuse to respond. So it is also a valid response.
It's just like, sir, in a set, when we create a set, there's inside the universe is the option n. So n will also be calculated when we calculate every items of the in the data.
Can you repeat?
Sir, I'm saying that when we prepare a set, right? Any set I mean calculation. So we calculate all the universe and data also, right?
Yeah.
So it's just like that. We have to calculate not people who are liking the thing, who are disliking, and we are not to somebody will like some students are there who prefer not to answer also, right? We have to calculate them also.
Yeah, you have to calculate. Yeah.
Sir, but the language is a little confusing there. If you see, can the analyst get a response? That means like he got a response, right? If someone is refusing to respond.
No, how get response? So refuse to respond is also a response, right? Suppose you are asking someone question and he can answer yes or no, or refuse or just walk away. So
no, refuse to respond is like a null response, right? It doesn't.
It is also a response. Refuse to respond shows like I can also suppose for a question all the users refuse to respond, right?
Yes, sir. So, sorry to interrupt you. Please don't mind. So basically, if someone responds with a yes, you can map that to a value of 1. If someone responds with a value of no, you can map it to 0. But if they don't respond, you don't have a mapping. It's basically
I
like
can map it to 2. It's all created by us, right?
But the language is very confusing in the question. I mean, it's like if he's getting a response, that means it's not refusing to respond.
No, refuse to respond is also a response in general. It is nowhere mentioned.
When you say it, it makes sense. But if you see it, the language, it is confusing there.
No, I don't think it is confusing. Everything is pretty clear. Each student, whether they like the movie or not, so students for now has 2 options. Now student can answer the question or refuse to respond. So he has 3 options to answer that survey, right? It's pretty clear from the question statement. Don't think there is any ambiguity.
So now if I say nothing, you would say that you didn't get a response from me, right, sir?
That's something different. I'm not
That's
doing
exactly what I was referring to, sir, actually.
I'm not doing any survey.
What sir is trying to say that every student has 3 options. He has to choose either 3 of them. Either he can respond, or he can not respond, or he can give rating. That's it. So possibilities are 3. You have to calculate.
I agree that the possibilities are 3, but the way the question is worded, it is
how it should be worded.
I agree with Saad actually, just little bit modification. Either he can choose to respond or he can not to choose to respond. But within only choose to respond, he has a dislike or like. Okay,
yes.
so basically 3 responses are there.
Yeah, that's what written here, right?
Yeah.
Answer the question or refuse to respond.
Yes.
Yeah.
So if you answer the question, you have a 2 possibility, that is dislike or like.
Yeah.
And
so that's mentioned over here, right? Like the movie or not.
Yes, sir. Yeah. So basically 3 responses are there.
Yeah.
So we have to calculate 3. So 3 to the power whatever the answer is. Like if somebody has 5 students, then 5 3 to the power 5.
So how it should be framed according to Avinash, right?
Yeah.
Yeah. So how it should be framed so to make it more clear.
Please give me a minute to think about this.
Yeah. Till then, any other doubt from this
Yes, sir.
assignment?
Yes. Yes, sir. I have doubt in practice assignment. Can I
week
narrate
5,
week 5, sir. Can I narrate the question?
Yeah.
How many numbers between 0 to 1 billion can be formed using 0, 1, 2 digits? Repetition is allowed.
Yeah. Okay. Let me just open that assignment. How many numbers between 0 to 1 billion, right?
Yes, sir. 0 to 1 billion.
This one you're at, right?
Yes, sir. Yes.
Okay, so how did you approach this one?
Sir, I try to solve it by taking each and every case.
Each and every case. Okay.
Yes, number will be 1 between 0 and 1 billion means from 1 to
this number, right?
Before 10 to the 191. And when the digit is when the number is of 1 digit, number is of 2 digit, number is of 3 digit.
Yeah, till 9 digits you can go.
Yes, sir.
Right?
I try to solve it by this way. And somewhere I lost in calculation. I could not find the right answer, sir. But here I want to know is my approach right?
Yeah, if your approach is right, you can do like that. Okay. Both will give you the same answer. You can do like that. The only thing that would matter is the time consumption for that question. Okay, because you have to make cases like for 1 digit, you will have 2 ways only, right?
Yes, sir.
Then for 2 digits, at first place you could have any 6 cases, right? Then you similarly have to do it for all 9, then add them all. Both will give you the same answer at the end.
Okay.
By the given approach is clear, right?
Yes, sir.
Sir, Avinash again.
Yeah.
So maybe we could have worded this like, what are the number of possible combinations of answers that can
combination term we cannot use for it. It's not covered yet.
Okay.
We are also have some restriction. If I use a combination term, it is not taught in the week 5, so I cannot use the word combination selection, combination or permutation in the question, right?
Okay. Okay. Without using combinations and without using the word responses, you say it's not possible to frame the question.
Combination and permutation, because it is taught in week 6 only, not in week 5.
Okay. Okay, but I actually was confused because the same word is used again, response. So
if you read the question, I think 2-3 times, it would give you more clarity. That's the major.
It's okay. So can I ask a different question unrelated to this?
Yeah.
So I actually registered for the course, but I have a conference on July 10th, which coincides with the day of the quiz too.
For that, you have to mail to the support team.
I actually mailed them, but they responded with like, the deadline has been extended. I did not understand which deadline they were referring to.
Okay. Can you ping me your roll number?
Just a minute, sir. I'm checking it.
Yeah.
Sir,
I will ask. Yeah.
In the previous question, which I asked about how many numbers between 0 to 1 billion.
Yeah.
So the solution given in the practice assignment, how does it cover all the cases? I'm just a bit confused in it. How does it cover all the cases? Yes, sir. In this solution.
See, in general, you have to make 9-digit number, right?
Yes, sir.
3, 4, 5, 6, 7, 8, 9. So if I put 0 at the first place, it would cover my cases of 8-digit.
Yeah,
if I put
8-digit.
0 in the first to 7-digit. If I put 0 in all the 8 places, that would cover my 1-digit cases, right?
Yes, sir. 1-digit.
So in general, what we are doing is, for all places, we are assuming that there are 3 possibilities. We are letting them put 0 at the any of the places also, right? Then there would be only one case when all my digits would be 0, right? You have 0 at all the places in one case. So if I subtract that case, because my number should be in between 1 to this, right?
Okay.
It's nothing but 0 and 9.
Okay.
Okay, yeah. Now we can actually move to week 6.
Sir, I sent you my roll number on Zoom chat.
Yeah, take a number.
Thank you, sir.
Okay. Okay. Now, what are like activity 6.1? Any doubt?
Sir, question number 4.
Sir, 4.
Number 4.
Sir,
Okay.
before moving on to questions, can you like give a brief summary if you don't have problem, because facing some issues.
Have you gone through the lectures?
Yeah, I have gone through once, but I think I should have gone through once more. Because there are some things that I think we have to learn again.
Okay. So I think
it would be
let's
fine
see
if
that
you give,
today's
otherwise I can
discussions. Yeah, in today's discussion, we will see what concept. Otherwise, you can also arrange one session by Professor Usha Ma'am for week 5-6 if you guys need.
Yes, sir.
It would be beneficial, sir. It would be beneficial because this week topics are a bit confusing for a non-maths background.
Yes, sir. I agree with him.
I am from medical background, so these topics confuse me a little bit.
Yes, it's very confusing. This too.
It would be so helpful, sir.
Yeah, I will ask Usha Ma'am if she can take one session on it. Otherwise, we will take it. But we will have one reading session on week 5-6. Okay, in how many ways can 5 distinct books be arranged in 2 bookshelves?
Sir, here we can use permutation formula, no?
Yeah, arrangement is happening, right?
And
but here you have 2 bookshelves, so you kind of combine
the
them.
value of R will be 2.
Suppose this is your bookshelf 1 and this is your bookshelf 2, right? So what all are the possibilities? In general, you have 5 books, right? So you can have all the 5 books in bookshelf 1 and none of the book in bookshelf 2, right? Or you can have 4 books in the bookshelf 1 and 1 book in the bookshelf 2. Or 3 over here too. This step is clear, right?
Yes, sir.
These are the possibilities you can have. Now, what happens is, out of those 5 books, in how many ways can you select 5 books for bookshelf 1?
One
way.
One way, right? Or in other sense, 5C, 5 ways, right? Because now we are introduced to the combination and permutation. Right? And now after selecting, okay, so I have selected the 5 books. Now I have to arrange it in the bookshelf 1. In how many ways can I do it?
Factorial 5.
Factorial 5, right? Here, 0 books, right? So only one way. to arrange 0 books in bookshelf 2, right? So if you compute it, it would be 120 days for this case. Is it clear till this step?
Yes, sir.
Okay. For the second one, out of these 5 books, I have selected 4 books for the bookshelf 1. In how many ways can I do it?
5C4 ways, sir.
Let's see more. Okay, now I have to arrange these 4 books in the bookshelf 1 also, right?
Factorial 4 ways.
Yes. For the second bookshelf, there is again one way only, right? I have to select one out of remaining 1 book. I have to select 1 book, and I can arrange it in 1 factorial ways, right? Is it clear? Or any doubt? No.
Yes, sir.
So again, if you see, it would be 120 ways a week. For the third one, I need 3 bookshelves, 3 books in the bookshelf 1. So first I will select 3 books, right? Which can be done in 5C3 ways. Now I will arrange these 3 books in 3 factorial ways, right? Now I have already selected 3 books for bookshelf 1. I'm left with only 2 books. Both the 2 books are for this to be selected for bookshelf 2, right? And can be arranged in 2 factorial ways. Is it clear, or anyone having doubt in these steps?
Clear.
Similarly, if you compute it for all, it would all be 120 days. And here, if you notice that the word arrangement was used, right? Arrangement means permutation.
Yes, sir.
So this is also permutation. Okay, let me just show you. So suppose I'm taking this term, 5C4 times 4 factorial, right? So you know the formula for combination?
Yes, sir.
Yes,
5
sir.
factorial.
Right? It gets cancelled out, which is nothing but 5 factorial upon 1 factorial.
5P.
5P4, right? So it is a permutation. Or arrangement. So don't get confused by I'm using C5. I'm multiplying it by this to compensate for the, or to convert it into permutation term, right? Arrangement, permutation, order matters. Clear this step? You can see 2 raised hand. You can see. Yes, Ankit. Ankit, Purama, any doubt? You have raised it.
Sir,
Yeah.
How this question is different from what we solved with the
It's the same. I told you that there are 2 ways to solve a particular question.
Okay, matlab, it is the same concept.
Not the same, but here order also mattering, but in that case order doesn't matter. Because they were yeah.
So here in general we are selecting the book first, and thereafter we are arranging in the bookshelf.
So whenever you are arranging, it's permutation.
Yeah.
Okay. So even though I'm writing it in terms of combination, I am transforming it into permutation by multiplying. So in general, permutation is used.
Yes, sir.
Okay, sir, and there we are not arranging the people.
Yeah.
We are just putting them.
Yeah. Okay. So see, whenever the word arrange, it gives you a clear idea of permutation, right? And order matters.
Okay, sir. Next time I will remember that.
Sir,
yeah.
Sir, in graded assignment 5, question
Yeah.
number 2, sir.
Yeah.
Sir, that in that arrangement is important, no, sir?
Let me see.
No, arrangement means if
No,
all the
arrangement is
classmates are distinct, no, sir. Not the arrangement. All the 7 classmates are distinct, no, sir.
yeah.
Yeah, then like we pick one, how many ways we can pick one person? That is 8. Then plus how many ways we can pick 2 persons? That is 8 into 7. Then again 3
8 into
plus
7
for
upon
3
2
upon, why upon 2, sir?
because 8 into 7, right? So it means
Yes, sir. 8 into 7 for if 2 students are in the photo.
okay. Suppose I have selected C1 first and C2 second,
Yes,
or I
sir.
have selected C2 first and C1 second. These two are same case because only these two will be in the photo, right? Along with
Yes,
teacher.
sir.
But in 8 into 7, these two are considered different cases. To compensate
those
for it,
two
we
are
need to divide by 2.
okay. That means now I am doing arrangement. If I do 8 into 7, even
Yeah,
I
that's
am
the
considering arrangement also.
yeah.
But if
To
I
make
divide
it
it by
selection,
2,
yeah,
then I will not consider arrangement.
yeah, you will consider only selection.
Okay, sir. In that week, I think we didn't get any distinction between these two, sir.
Yeah, because the terms permutation and combinations are coming in this week. So that's why you were had to use only counting principles to get these things done.
Okay. I mean, in lectures in week 5, did we get any such
In practice assignments, we had enough
information?
questions regarding it.
Okay. In practice assignment, we got those, no, sir?
Yeah.
Okay. In this 6th week, we'll get about all those clarity, no, sir?
Yeah, 6 we will give you more clarity on this.
Sir, in that, how do we, like, that is done by combinations, this
Yeah.
question. Second one is done with combinations, no, sir?
Yeah.
Okay. If we want to do it generally, then how do we recognize these questions, sir?
Okay. So another way. Okay. So first way was that each student has 2 ways, either to be in photo or not, right?
Yes, sir.
That was the 2 times, right? Another way to approach is, suppose I have 3 students. So what are the cases, right? Only one student is there along with teacher. 2 students are there, or all 3 are there, because it is given that at least one student should be there, right? So one student I can select in 3 ways, 3C 2 ways, 3C 3 ways. I can simply add them all, right? Why I'm adding? Because either this will happen or this will happen. It is not the simultaneous occurrence, right? So if I add subtract 3C0 to this term, then by the property that it would be 2 cube. Your voice is big.
Sir, where will we get this formula 2 to the power?
Okay, so in general, this is the formula. It will be covered in the lectures as well. And C2, add them all to it, it is equal to 2 raised to the power n. So here n is 3, right? 3C0, 3C1, 3C2, it is cube. Okay.
Sir, previous question, book self question, sir.
Yeah.
Was it simultaneous occurrence, sir?
Every case is a simultaneous, within a case is simultaneous occurrence, right? Here
overall it is non-simultaneous, right?
Overall it is simultaneous, but there are also different possibilities, right?
Sir, if we don't know combinations, how do we approach that question then?
Each student has 2. Which question? This one?
No, sir, that one, sir. Second one.
Each student has 2 ways.
Activity question.
Either activity question. Okay, let me give you this one. See, here in the first case, the book's arrangement is simultaneous, right? But
yes,
within the cases, it is not simultaneous, because either this will happen or this will happen or this, right?
So what should we do, sir, when it comes to EMQ type?
in EM2 you won't be having such things. So
Okay, sir. Okay.
where this ambiguity would be here. Either it would be very clear that you have to arrange 4 in the first and 1 in the second, then tell. In that case, it would be simultaneous, right?
Yes, sir.
Or it would be broken down into some steps where it would be very clear whether it's simultaneous or not. Such ambiguity won't be there.
Oh, okay.
Okay. Activity 6.1, any other doubt?
No, sir.
Okay, 6.2. Okay, till which lectures have you guys covered the syllabus?
Yes, sir. I've gone through the video, but I've doubting lecture, sir. Lecture 3.
Lecture. Okay, do you guys do activity just after watching the lectures, or like watch all the videos and then do all the activities?
Sorry, sir. Not lecture
No,
3.
sir. Just after watching previous
Tutorial
lecture,
3,
we
sir.
will go to activity question.
Which 6.2?
No, sir. I had doubt in tutorial 3 questions.
Tutorial 3. Okay.
Yes. First and
I
second.
have a doubt in activity 6.3 also. 6.4, sorry.
Okay.
First and second question, sir.
There are 2 questions in this tutorial. Let's see.
There are 4 questions, sir.
Okay. If a coin is to be tossed 7 times, in which at most. Okay, what do you mean by the most thing?
At most things, at most maximum.
Maximum, right? Okay. Toss 7 times the number of outcomes in this 64. Okay, these are the 4 options, I think. Right? So you have to choose the correct options. Choose the correct option. These are 4 options.
These are 4 questions, sir. 4 different questions.
No, 4 options. See, the question is only one. Choose the correct options.
Yes, sir. Yes, sir. Yes, sir.
This
Correct.
is option 1, right?
Yes, sir. Option 1.
Okay, so you have doubt in option 1 and option 2, right?
Yes, yes, sir. Option 1 and option 2.
Okay, if a coin is to be tossed 7 times, the number of outcomes in which 3 head appears. Okay, so you have to find the number of ways, because you are tossing the coin 7 times, right?
Yes, sir.
You have to find the number of ways in which you will get at most 3 head. Right?
Yes, sir.
Okay, so what all are the possibilities? At most 3 means you can have 0 heads, 1 head, 2 head, or all. You got 3 heads, right? You cannot have more than that, right?
Yes.
So for the first case, it means you should have tails at all the 7 places.
Yes, sir.
Okay. Which can happen in only one way, right?
Yes.
Now for 1 head. 1 head can be at any of these 7 positions, right? So what I will do is first I select any one position of these 7, which I can do in 7C1 ways.
Yes, sir.
Right? And that position is fixed with heads. Rest all we should have tails, right? So remaining 6 can be filled with tails in only one way, right?
Okay, yes.
7 is. Similarly, 2 heads. So I can have heads at any of the 2 places of these 7. So first I select any 2 positions of these 7, which I can do in 7C2 ways, right?
Yes.
Then I fix those 2 positions with heads. Now remaining 5 are to be filled with tails, right?
Which can be filled in one way.
7C2 is nothing but 21 ways, right? Now 3 heads. Similarly, 7C3 times 1, right?
Yes, sir.
I think it would be 35 ways, right?
Yes, sir. Got it.
So 35, 56, 64. So for option 1 is correct, right? Okay, so option 2, now you can try again. You know how to approach this, right?
Yeah, yes, sir. I will try.
Okay, activity 6.4, some was saying.
Question number 1, sir.
Question number 1. Out of 6 consonant and 4 vowels, how many words of... Okay, so how did you approach this one?
Sir, in this order matter, so
Yeah.
6 consonants are there, so 6 P3 into 4 vowels are there, so 4 P2. I multiply these two, but the answer is not matching.
See, here it's not like we are how many? Okay, 6 consonant and 4 vowels, right?
Yes, sir.
4 vowels, out of which we are using only 3 consonant and 2 vowels, right?
Yes, sir.
Okay. See, here it's not like you have to arrange any 4 of them or any 2 of them, right? The question first you have to do is you need to first choose any 3 consonants.
Yes, sir.
Which you can do in 63 ways, right?
Yes, sir.
Now you have to choose 2 vowels of these 4, which you can do is 4C 2 ways, right?
Yes, sir.
Now you have a collection of these 5 objects, which you can arrange in 5 factorial ways.
Okay, sir.
It's not like we are arranging 4 consonants first and 2 vowels then. First, you need to gather all your objects at one place and then arrange them, right?
Okay, sir.
Gather all, arrange. Clear now?
Yes, sir.
Okay. Anyone, anything else?
So tutorial 6.
Okay. The first letter is of how many ways can be arranged 26 letters of our alphabet. Yeah. So that first letter is a vowel.
Yes, sir.
And there are exactly 8 letters between A and B. Okay.
So how can we generalize every position for A and B? The solution.
Have you gone through this video?
Yes, sir.
Okay. So at first step you are stuck. Like how did you approach and what step are you getting stuck?
In first case, in which in first word we had fixed the letter A, so that I understood. But sir, in second case, there is an option in which we are multiplying 16 position. That 16 number I was not able to get from where 16 came in the solution.
Okay. See, when we are fixing A, right? So how many vowels are there in general?
5, 4 left.
A, I, E, right? And then
A, E, I, O, U.
These are the 5 you have, right? So first condition is the first letter should be a vowel, right? And second is in between A to B there should be 8 letters in between, right?
Yes, sir.
So suppose if I fixed A at first place now, so it implies that at the 10th place I will have B, right? Only then I would have 8 alphabets in between A and B, right?
Okay.
So now these 2 are fixed. I can arrange others at the remaining 25 places, right?
Yes, sir.
Now other case will occur. Suppose I fixed E at the first place. It is also a vowel, right?
Yes, sir.
And then to meet this condition, 8 alphabets in between A to B. What can happen is A at second place, B at 11th place, right? Or A at third place, B at 12th place, right?
Yeah.
Fourth place, 13th, so on up to
7.
26th place. It would be, I think, 2, we have 11, 3, 4.
17.
That's it. Seven. Right? So as you compute for this single case, there are 16 more to be considered, which are same as that.
Yeah, that's the 16 thing. Okay, so understood.
Okay, anyone, anything else in week 5, week 6?
So in week 6, the formula which has been derived for circular arrangement, in case when anti-clockwise and clockwise arrangements are same, not different. Yes, can you explain the formula once again for it? How is it derived?
Okay. Suppose I have 3 objects, A, B, and C. Okay? If I arrange them in the linear form, I have a starting point, right? And I have an end point. So in general, I can arrange it in 3 factorial ways, right? You know this thing for now.
Yes,
for linear. But what happens in case of circle is we do not have start and end point. Because you don't know at what point it is starting. Circle. For a line, you know that it starts here, it ends here. But not in case of circle. So what happens is, see, okay. Six, right? Suppose these are the 3 positions. Okay. So what all can happen is A is here, B is here, C is here, right? Or A is here, B is here, C is here. Yes, C is here. Or you can have B here, A here, C here. Okay. And another book can be B here, A here, C here. Okay. So now if we read it, let's say clockwise, so you will read it as ABC.
Yeah.
Right? You will read it as ABC. Right? You will read it as ABC also. You will read it as ACB, right? ACB. ACB. So if you read it clockwise, you will have only 2 ways distinct, right?
Yes, sir.
Okay. Now suppose we are saying clockwise and anti-clockwise are same. In that case, what would happen is instead of counting them clockwise, I consider it anti-clockwise. Then also it becomes ABC, ABC, ABC. So if clockwise and anti-clockwise are same, my cases are half, right?
Yes.
That's only one. Is it clear? Or you can do it, you can also do it for head. In that case, these all will become AC. So that's when the clockwise and anti-clockwise are same, our cases are half.
Yes. That's why we divide it by 2.
Yeah. Okay. Anyone, anything else? Anything from week 5, 6? Okay, so how is the exposure to permutation combination till now?
So it's very confusing.
Okay, so have you, any one of you did bonus practice assignments for EMQ? These, if you go through this, I think many things would be a bit more clear on how to approach the questions and all. And also in part 2, we have EMQ. And
And
I
I have
think you
one
want to,
doubt. Practice assignment 6.
okay. Okay. And yeah, part 2 weightage is 20% of these reading assignment, and there is negative marking also introduced over here. You all aware of this?
Yes, sir.
You can click on this to see like how negative marking would be applicable to these questions. Okay, week 6. Which question in practice assignment?
So David wants to create an account learning application. Username, password question.
Okay, what's the question statement?
David wants to create an account on learning application in which he has to provide a username and password.
This one,
Yes,
right?
this one. Yes, sir. So I have doubt in last option, E option.
D option. D option. Okay. And wants your distinct digits. He can generate. Okay.
So in last option, how can we find about distinct digit? Sir, I was not able to set up a case for distinct digit.
Okay, let me just see. First, I want to create an account. Okay. The username must be such that first 5 characters are alphabet followed by 2 or 3 digits. Okay. The password must contain 7 characters. Out of it, first 2 are alphabets. Okay, 5-digit odd number. Okay. The last digit of password must be larger than the second digit. Okay. No digit should be 0. If you cannot use alphabets, password is already used, then which are the following is that true? Okay. Okay, so how did you approach this one?
So for the username, for the first 2 alphabet, 5, we don't have to use 4 that we already use in David name. So 26 minus 4, it's 22. So for two letters, there will be 22 into 22. For the numeric digit, we have to. I had made the cases for 1 to 9. For 1, we have 2 cases. For 3, we have 2 cases. In that way, in starting digits, I have taken for 9 9. Sir, I had not used the formula. I had used the basic multiplication formula, addition multiplication rule.
Yeah, that's what you have to use over here. Okay. So
sir,
these
last
5
option.
number. Okay.
So in last option, it is saying we want
No
to use
2
a
digits are same. Yeah. Okay. See, no 2 digits should be same. It means repetition of digit is not allowed, right? Repetition of digit is not allowed, right?
Yes.
So And another condition it was saying is that it should be an odd number, right?
Yes.
For odd number, it means at the last place you could have 1, 3, 5, 7, and 9, right?
Sir, and last bit should be greater than the second last one.
Yeah, and second place should be less than last, right?
Yes.
Okay, and no digit should be 0.
Yeah, no digit should be 0.
So numbers which we are allowed to use is 1 to 9, right?
Yes, sir.
So now suppose if I take 0 as my last, like 1 as my last digit, in that case I cannot have my second place to be less than this, right?
Yes.
So 1 is not a possibility for last digit, right?
Minimum should be 2.
So now we have only 4 options for last digit, right?
Yes, sir.
So suppose if I'm using 3 over here.
Yes, sir. For 1 or 2, it will be a 4, and for 3, 4, it will be a 3, then 2, then 1. So total it comes to be a 20.
For second place, I can use either 1 or 2 only, right?
No, sir.
Second place should be last in the last place, right?
Sir, it is given for last.
Second last, place.
Second last, not for whole.
The last digit of password, second last digit. Okay.
Only for second last. So for second digit, we can use 9 digit, 0 to 1 to 10, 1 to 9, any of the.
No. Let's first fix these things. So here I can have only 1 or 2, right?
Yes, sir.
So only 2 ways to fill it.
Yes, sir.
For the last place, I had 1. So now I am left with only 7 more digits, right? And I need to fill these 3 places.
Yes, sir.
So for the first place, any of the 7, any of the 6, any of the 5.
आगे वाला है, आगे वाला cancel करते हैं.
Okay, repetition नहीं होगा.
Right? 7 times 6 times 5 times 2 times 12. Right?
Yes, sir.
Now, okay. Now suppose 2, 3, 4, 5. I have fixed 3 we have done. Now I have fixed 5 at the last place. Right? Which can happen in one bit. For the second last, I could have any of the 1, 2, 3, 4, right?
Yes, sir.
1, 2, 3, 4. 4 ways, right? Now I have used 2 digits again. 7, 6, 5, right?
Understood, sir. I was doing mistake in 7, 6, 5.
Yeah. First fix those places in which there is condition.
Yes.
So you can, like, on the first 3 there is no condition. You can fill those position in last as well.
Yes, sir.
Okay. Yeah. Anyone? Anything else? Or shall we close for today? Yeah.
Let's call it a day, sir.
Yeah.
Next
sure.
time we will ask.
Okay. Yeah. Sure. Okay. Thank you. Everyone.
Thank you, sir.
Yeah, good night.
Good night,
One
sir.
more doubt is there. Hello.
Yeah.
Sir, in practice assignment 6,
Okay. Which question?
a coin toss bet is placed on 2 friends.
Can you tell me the statement, like how it starts?
A coin toss bet is placed between 2 friends, such that the person.
Coin bet toss. It's in week 6 practice, right?
Yes, sir.
This one, right?
Yes, sir.
Who wins 4 tosses first is the winner. Toss in a number of ways.
Sir, I was
Okay.
not able to visualize the cases that it has taken.
Bet can play out. Okay. So, see, suppose 2 players are A and B. Okay. Either of them can win, right?
Yes.
So what we will do is we will compute the cases where A win, and then we will multiply it by 2. So we will get, because cases B win will also be the same, right? So for both there will be same number of cases, right? Either A wins or B wins. Okay, so let's start with this cases where A wins. Suppose 4 toss happened and A wins all the 4, right? Or suppose 5 toss happen. Okay, I'm going to write it down like this. Okay, A wins all the first 4 toss, right? This is all possibility.
Okay.
Second would be in the first 4 matches, A wants 3 and B wants 1. And then fifth one is won by A. So 4 wins for A, right?
5.
5 matches are played. In the third one, suppose in these 5 matches, A wins. Okay, you cannot. Okay, A wins 3, B wins 2, right?
Yes.
And then the sixth one is won by A. So in the 6 matches, A won the bet, right? For the fourth one, suppose 6 matches are played. A won 3 and B won 3. And A won the 7th match, right? Clear till this step?
Yes, sir.
Okay, so here 4 matches was played, here 5, here 6, here 7.
One more case would be.
Now you cannot play 8 matches.
Both will win.
Yeah. Because as soon before going to 8th match, you will definitely have a winner. One must have won 4 matches, right?
Yes, sir.
So only possibilities are these 4 cases, right?
Yes, sir. Similarly, we will not do it for B.
Yeah, similarly, we will do it for C. First, we have to find the number of ways for each of them, right?
So then
first,
we can multiply by 2. It will be the same.
Yeah. So for the first, A won all the 4. It can happen in only one way, right?
Yes, sir.
Okay. For second, out of these 4 matches, A won 3 and B won 1. So B can win any of these 4 matches.
Yes, sir.
So there are 4C1 or 4 ways that B can win 1 match of these 4. In general, you have to place B in any of these 4 positions, right? You can do it in 4C1.
We can do it for A. It will be a 4C3, which is same 4C1 or
4C. Yeah, 4C1 equals 4C3, right?
Yes, sir.
Both equals 4. It's like you select one position for B. Similarly, for the third case, out of these 5, you need to fix 2 places for B, right? You can do it in 5C2 ways.
5C2 or 5C3?
Yeah, both will give you the same answer, right?
Yes, sir.
And for the last, out of 6,
6C3.
6C3, right? Remaining 3 goes to other one automatically.
Yes.
So these are the cases where A wins. Similarly, you can compute for cases where B wins.
It will be same.
It will be the same. So you can multiply it by 2.
Yes.
We will have to, sir, add both cases. Cases where A win and cases where B win.
Yeah, because in how many ways the bet can play. That's the question. It's not in how many ways can A win or B win.
Oh, yes,
Bet
sir.
can play. So either can.
Okay, sir. Either one.
Clear?
Yes, sir.
Yes, sir. Clear.
Anything else?
No, nothing.
Okay then. Yeah. Thank you everyone. Good night.
Thank you, sir.
Good night, sir.
Good night.